Hi, my name is Christine. Today we're going to talk about mycobacterial staining. Mycobacteria have high mycolic acids, which gives them a high liquid count. So in order to stain them, you have to increase your staining time and use special stains that do not have aniline bases in them. Use carbofucsin and auramine. The first stain uses carbofucin and it has to be heated up for at least 5 minutes. We also include a filter paper to get rid of all of the crystals that may appear when you heat carbofusin. To start this stain, drench the slide with carbofusin and then heat it lightly until it steams. Once the slide has started steaming, you let it sit for 5 minutes. After your stain has been on for 5 minutes, rinse with distilled water. It's important not to use tap water because it may contain environmental contaminants like Mycobacteria gordoni, which could lead to a false positive. So we use distilled water and we go gently around the edges. At this time, your filter paper can come off because we're not worried about crystals from any of the other reagents. Next, we use a decolorizer. It's acid alcohol. Acid-fast bacilli cannot be decolorized by acid alcohol, so that's why we use it. It's a very strong decolorizer. So once again, we pour on the decolorizer, and that stays for 2 minutes. After you've decolorized for 2 minutes, rinse with distilled water like before, gently around the edges. Careful not to remove any specimen. After you've rinsed, we add our counter stain, which is methylene blue. Any bacteria or fungal elements or yeast in the specimen will turn blue, whereas our acid-fast bacilli will still stain red. So if you see any blue background, it could be a contaminant or it could just be specimen. And once again, that stays on for 2 minutes. Rinse the methylene blue off after your 2 minutes. It's important not to blot dry any acid-fast bacilli slides. Instead, we stand them straight up and put them in a warm incubator to dry so that we don't touch them or remove any of the specimen. Next, we'll go over the auramine O stain. Auramine O is a fluorescent stain. We don't apply any heat when we're using auramine O. Instead, we just increase our staining time. This stains for 15 minutes. Our fluorescent stain is used for direct specimens. All the specimens that come back that are digested and decontaminated, they'll all have a fluorescent slide red within 24 hours. If we should happen to see any fluorescent bacilli on the slide, we'll try to confirm it with the Ziehl-Neelsen stain in order to call a patient positive. The only other time that we would use the Ziehl-Neelsen stain is if we get a culture that should turn positive. In order to confirm the presence of acid-fast bacilli, we would then again use the Ziehl-Neelsen stain. After the auramine O has been on for 15 minutes, rinse again with distilled water. We use another, just a second, acid alcohol decolorizer. And that stays on for 2 minutes. After your decolorizer has been on for 2 minutes, rinse again with your distilled water. The counter stain for our fluorescent slides is potassium permanganate. Potassium permanganate can stay on for up to 2 minutes, but no longer, in case we can pulse the fluorescence. We don't want to cover it up, so we don't want to counter stain for too long. Potassium permanganate can be rinsed off after 2 minutes. And similar to the Ziehl-Neelsen stain, we'll put it in the warm incubator until they are dry to the touch. When we're reading fluorescent slides, we read them at 20x, and you have to read at least 30 fields in order for it to be called negative. Compared to the Ziehl-Neelsen stains, you have to read 300 fields at 100x. So you have to stay there for a lot longer, meaning that your oramine stain is much more sensitive. So that's why we use it for direct specimens, so we can decrease the amount of time it takes to read them. The only downside to the oramine stain is that it might be difficult to pick up rapid growers. They might not pick up the stain as well as they would with the Ziehl-Neelsen